Okay, so here we're looking at matrix inverse in system of linear equations, competency 1, finding inverses of 2 by 2 matrices using the 2 by 2 inverse formula. All right, so let me just remind you what that is. A, B, C, D, inverse. This is one of the few formulas you really should memorize. It's equal to 1 over AD minus BC. It's called the determinant. You get that from this X pattern of the matrix. And then you multiply, you exchange the diagonal entries, D exchanges with A, and you negate the off-diagonal entries like that. All right, now, here we want to find x and y such that the inverses of 2x4y and x9 2y do not exist. Now notice that this matrix exists if and only if AD minus BC is not equal to 0. Okay? So it exists if and only if AD minus BC is not 0. So it doesn't exist if and only if AD minus BC is equal to 0. Okay? So that's going to give me the condition that these two inverses do not exist. So let me just call this A, and I'll call this B. So A inverse does not exist, gives me a condition on x and y. Okay. So A inverse does not exist. That tells me that, well, let's take AD minus BC. Looks like 2y minus 4x. 2y minus 4x. So 2y minus 4x must be equal to 0. On the other hand, the inverse does not exist. That tells me that, what? xy minus 18. xy minus 18 is equal to 0. Right. Now, this is not a system of linear equations because the x multiplies by the y here. But let's not get hung up with linear equations. You can still solve these equations very easily. You can rewrite this as y equals 2x. And then this one just says xy equals 18. So you can easily just substitute y equals 2x. That gives me x times 2x, or 2x squared, equals 18. So that tells me x equals 3. Or x equals plus or minus 3. And then y equals 2x means y equals plus or minus. Y equals plus or minus 6. Okay. So apparently, there are two possible solutions that we can check. So we have either x equals 3, y equals 6, or x equal minus 3, y equal minus 6. Okay? And you can check both of these that they both work. Right, you go up here, if x equals 3, y equals 6, well, notice something. If x equals 3, y equals 6, then here we have 2, 4, 3, 6. This column is a scalar multiple of this. If I have minus 3, minus 6, it's the same deal. So A is going to be a singular matrix, so there's no inverse. Now here, if I have 3 and 6, so here I have 3, 9, 2, 6. So the first row is a scalar multiple of the second row. We also, if we have minus 3, we have minus 3, 9, 2, minus 6. It's still a scalar multiple. So those two different possibilities are both possible. So we can say either this one or this one. And that gives me all the solutions. Okay.